In this lecture, we're going to talk about the precedence of logical operators available in propositional logic. Now let's try to understand why precedence is important. Precedence of operators helps us to decide which operator will get evaluated first in a complicated looking compound proposition. Now this is not very difficult to understand. Precedence helps us to decide which operator will get evaluated first. Suppose a compound proposition is composed of multiple logical operators. Then in that case, which operator will get evaluated first is the question of concern. Therefore, we need to know the precedence of operators in order to know which operator will get evaluated first. Let's consider one example of a compound proposition. P implies Q and not P. Now, as this compound proposition is composed of implication, conjunction, and negation. Now, which operator will get evaluated first is quite important for us to know. Now, let's consider the precedence table in order to understand which operator will get evaluated first. Now, here is the precedence table. These are the operators, their names, and precedence. Negation is having the highest precedence among all the other operators. Then after conjunction comes up, then disjunction, then implication, and then bicondition. Now according to this table, negation will be performed first, then after conjunction, and then implication. Isn't that so? Let's say P is true and Q is false. Then, what would be the truth value of this compound proposition? Let me write this compound proposition once again. As P is true, therefore not P becomes false. And Q is also false, therefore false and false becomes false. As P is true and this whole compound proposition is false, therefore true implies false is finally false. This would be the truth value of this compound proposition P implies Q and not P. If we directly go without using the precedence table, then it may produce different result. Therefore, precedence of operators is very important for us to know. Now let's consider one problem. Construct the truth table for the compound proposition below. P implies not Q and not P equivalent not Q. This is the biconditional operator, negation operators, conjunction operator, and implication operator, right? Of course, this is quite complicated looking compound proposition, and without knowing the precedence of operators, we cannot calculate the truth value of this compound proposition. Here we need to construct the truth table. Now, let's construct the truth table. Okay, let's write all the different combinations of P and Q first. First combination is true-true, then true-false, then false-true, and then false-false, right? After that, as we need to calculate not P and not Q, therefore we need to consider the combinations of not P as well as not Q. As P is true, not P becomes false. Again, P is true, therefore not P becomes false. This one will be true and this one will be true. In case of not Q, as this is true, this is false. This is false, this becomes true. This is true, therefore this will be false. And this one is false, therefore this is true. Now we need to consider the precedence among the conjunction, implication, and bicondition. Conjunction is having the higher precedence as compared to implication and bicondition. Therefore, this will get calculated first. That is not Q and not P. Let's suppose not Q and not P is equivalent to R. As R is not Q and not P, what are the truth values? False and false is false. True and false is false. False and true is false. but true and true is true. Now, as we know, implication is having higher precedence as compared to by condition. Therefore, this will get calculated first. P implies R. As true false means false, true false means false, false false means true, and false true means true. Let me rename P implies R as S. Okay. Now this whole compound proposition from here to here is S. Now S is equivalent to not Q. Let's calculate that next. S equivalent to not Q. Let's calculate this particular compound proposition. False false means true. False true means false. True false means false. True true means true. So the final answer of this compound proposition would be true false false true.